Ladies and gentlemen, thank you so much for your attention here. Today, we discuss a flexible, low power, and wide range DisplayPort PMA. I'm CC Chen from Silicon Creations. First of all, we'll provide an overview of Silicon Creations. Silicon Creations is a leading provider of mixed-signal IP, including PLs, oscillators, clocking solutions, and high-speed interface SerDes. We were founded in 2006, so have been developing IP and supporting customers for more than a decade and a half. Because of our high-quality IP development, we are profitable and growing. We are headquartered in Atlanta, Georgia, and have our largest design center in Krakow, Poland. We have over 420 customers, including over 180 China customers. We have IP available in all TSMC FinFET processes and mass production down to 5 nanometer, with 3 nanometer in production now. Lastly, we have won many awards for our IP and service, including the TSMC Analog Mixed-Signal Partners of the Year for the last 6 years running, 2017 to 2022. Let's look at our highest value IP PLs, which are available from 3 nanometer to 180 nanometer. Impressively, our PLs are on over 10 million TSMC wafers, with a handful of PLs per chip and hundreds of chips per wafer. This means there are literally billions of our PLs in production. Obviously, we have a neat and robust design and strict QA flow to support this. Furthermore, we are ISO 9001 certified and participate in TSMC's IP 9000 program. As you can see, our PL products include general purpose integer N and fraction N PL, low jitter PLs for SerDes and ADC clocking, low area, low power PLs for digital clocking, microwatt PLs for IoT applications. For example, multiplying 32 kHz to hundreds of megahertz. Lastly, we also have PLs certificate for automotive applications. Silicon Creations provides a wide range of SerDes products covering 4 nanometer to 180 nanometer, 100 megabit per second to 33 gigabit per second, owing to our advantage of robust architecture, well-proven, low risk, low power. We have over 75 different SerDes IP in production or currently in development with a wide range and diverse customer base. Our multi-protocol SerDes is the foundation of several FPGA families, so it's designed and proved to be flexible and robust, supporting many different protocols. To be specific, our SerDes have a wide and continuous tuning range, low power with very low picojoule per bit, excellent jitter tolerance, jitter cleaning with an extra low bandwidth digital PL is integrated. We support burst mode operation. Lastly, we can deliver special purpose and semi-custom PMAs. In addition to 2 major IPs, Silicon Creations provides other complementary analog IPs such as LVDs from 5 nanometer to 180 nanometer, free running reference list oscillators, frequency generator, FG for DFS, delay to digital converters, DDC, row jitter clock distribution blocks in the form of CML buffers and mux, band gaps, and power reset PORs. Next, we will give an overview of a DisplayPort DP system. DisplayPort interface is becoming more popular since it not only supports external box-to-box interface, but also supports emerging interface within smartphones, tablets, notebooks, and other systems that incorporate a display panel with a video or graphic processor. In addition to the DisplayPort, unidirectional main link supporting the data transmission. The DisplayPort has a bidirectional auxiliary channel link and a unidirectional hot plug link from sink to the source to support link management and interrupt requests respectively. For the unidirectional main link, we usually call the transmitter a source device and call the receiver a sink device. For example, the source device could be a video or graphic processor unit GPU, and the sink device could be a controller of a display. Specifically, the main link should support 1, 2, and 4 lanes configuration among with the chosen line rate for different throughput or bandwidth needs. Both the line rate and number of lane configurations should be communicated over the auxiliary channel between the source and sink devices. For the variety of line configuration and wide range of the line rate of the main link, Silicon Creations is very flexible to support the requirements and to provide either a source or a sink IP, even though we do often provide both TX plus IX IP for the self-test. The auxiliary channel aux used for link measurement is an AC coupled bidirectional signal path and operates at a 1 megabit per second transfer rate of Manchester coded. Fortunately, Silicon Creations provides a low voltage differential signal LVDS bidirectional IP as the electrical subblock to meet this function robustly. Let's discuss a few key performance we need to meet the requirements of the DisplayPort. The first requirement of a DP sync device is the jitter tolerance, which means the DP sync device input data clock recovery CDR must track the input sinusoidal jitter for any jittery input data. That means the CDR must have a wide tracking bandwidth across the full range of a DP rate from RBR to UHBR20. In addition, during this link training in a frequency loop, the device must be able to either lock to the D10.2 pattern or optionally to a local reference clock. The second requirement of a DP sync device on top of the JTAL is the channel equalization, which means the DP sync device must equalize a bandwidth limited data at the input of the device under an inter-symbol interference ISI. Therefore, the DP standard defines the reference equalization EQ, such as continuous time linear equalizer CTLE for HBR and HBR2, and extra one-tap decision feedback equalizer DFE for HBR3 and UHBR, such that the partner ecosystem can follow together. In other words, to pass DP's JTAL compliance test, any device must outperform the reference EQ to equalize a nearly closed eye to an open eye with a good margin. To meet the DP's JTAL with a decent margin, one of the key features is to apply the band-band CDR, which has a wide tracking bandwidth over PPT data rate robustly. In addition to the phase tracking of the CDR, we also leverage the wide tuning range ring-based PO to meet the wide frequency tracking range of the DisplayPort. Please be advised that our ultra-wide range PO does not require any frequency calibration and can jump different data rate easily only through the link training, like to D10.2 pattern, or by proper programming setting, like to the reference clock. Again, the same PO topology has been widely used from 3 nm to 180 nm in mass production. Then, to outperform the reference EQ with a good margin, our two-stage programmable CTOE with adaptation can compensate for any high-frequency channel loss across the full range of the DP data rate. To further improve the receiver's input sensitivity or tolerance a lower swing from the source device to save the power at the link partner, another programmable multi-tap 5 or higher DFE with adaptation using a finite state machine can be used flexibly. Another key feature is our programmable discrete bus width, which is suitable for AB10B, 128B, 130B encoding at different DP rates, RBR, HBR, up to UHBR. For the DP source device, not only the output swing level should be adjusted, but also the equation level of the FFE can be programmable, since the trade-off between the power consumption of the source device and the signal integrity of the main link. For example, if the cable between the sink and source device is short, the source output swing can be minimized to save the power consumption. On the other hand, if the cable connected between the sink and the source device is very long, the channel loss will be a lot, and the source device output swing and FFE must maximize to have the link transmission robust. Therefore, the DP defines 6 levels output swing level with a minimum of 200 mV P2P differential and 4 pre-emphasis levels. To meet the DP's source device electrical requirements, our TX driver can provide 6 bits highly programmable swing control and 3-tap FIR to cover both swing and FFE required range and resolution of DP spec reliably over PVT. In addition, the clock of the DP source supports either the spectrum clocking generator or the programmable bandwidth to meet the DP specification. As the sink device, the source device has programmable serial bus width suitable for AB10B or 128B, 130B, encoding for different DP rates, RBR, HBR, up to UHBR as well. In addition to the key features for meeting DP requirements, we have additional features shown below. The DP does not define how the debug should be done. Therefore, inherently, we only have access of either the pale data at the source and the sink device or the serial data at the link interface. Obviously, if something went wrong, we don't have any visibility on those circuit blocks circled in red. So, we need to design for testing DFT feature inside the TX and RX. For example, how can we check signal integrity SI at the receiver X or Y internally, which is CTOE output or DFE output of the sink device respectively? To mitigate these DFT impairments, we added a built-in internal eye scan for the visibility of the internal SI. The built-in PRBS generator and checker will manipulate the internal eye diagram from the reported bit area as shown here. even though the DP is a unidirectional main link such that only a TX or RX IP for either a source device or a sink device is needed. We do often provide both TX plus RX IPs for built-in self-testing based additional feature to help customers to save test time cost. Basically, this DFT enhancement tool may need built-in PRBS generator and checker along with 4 loopback modes to save testing time and cost. The loopback mode we call are far-end serial, near-end serial, transmission gate near-end serial, and PCS far-end parallel loopback. Let's go through our DP measurement results. First of all, the jet out measurement setup is often defined in any standard and shown here. The major jet out of our TSMC 40LP DP sink device shows the overlay graphics over PVT on the right in HBR and HBR3, which indicates the robustness of our CDR design. For much of the frequency range of sinusoidal jitter added to the data, our CDR even checked up to the modulation limits of the bit error rate tester. The major jet out also shows a consistent eye width margin of about 0.2 UI. We've heard that some of our leading customers provider cannot pass the test robustly. The major Apple 1 gigabit per second eye diagram of the source device in typical corner is wide open, so it can meet the HBR3 spec over PVT for sure, even though this major device was applied to a featured BGA package. Our other PMA in TS40LP can still apply a wire bond package flexibly to meet customers' needs. Finally, let's summarize. Silicon Creations has been providing high-performance, robust, production-worthy PL clocking and SerDes solutions since 2006. These PLs have been produced by TSMC in the billions, making them among the highest volume analog mixed-signal IPs from 180 nm to 3 nm. Specifically, Silicon Creations had extensive experience developing and supporting DP and EDP sink over source main link and outside link PMA IP, offering solutions in a wide range of process nodes from 55 nm down to 3 nm. The architecture of our multi-protocol PMA not only supports all the DP requirements robustly, but also being very flexible to meet customers' special needs, like a low TX output swing, low leakage power for the added TX loopback usage, and low power solution over very wide range, RBR to UHBR20, through an easy and robust PO topology. The DP PMA will also provide built-in DFT options for customers to speed up silicon calibration and reduce the test cost. For RBR, HBR, HBR2, up to HBR3, 8.1 gigabit per second, wire bond package type can be applied to save cost. For example, we also have a wire bond package TSMC 40LP PMA for DP up to HBR3. Thank you so much for your attention. For more information, please contact sales@siliconcr.com.